Hello, Luke. Welcome to Lesson 45. So today we are going to take a little bit of a step back from the algebraic problems that we've been looking at lately. We've been looking at a lot of factoring, a lot of least common multiples, greatest common factors, common denominators, and all of that other stuff. So today we're taking a little bit of a break from that, and we're going to step into a different area of mathematics called statistics today. So buckle up. Here we go. We're going out for a little excursion in the land of statistics. So to begin with, let's talk about what statistics are. So I think that calls for a definition. So statistics are the branch of mathematics that deals with the collection, organization, analysis, and interpretation of numerical data. All right, well, that's a mouthful right there. But in simple terms, statistics is where we collect data from a certain event and we organize it and then we try to analyze it. And in particular, we often try to forecast future events or future occurrences of the data based on what we have already gathered, the information that we've already gathered. All right. So it's a completely different field of mathematics compared to algebra, but it does have some algebra concepts in it, or some of the things that we do in statistics require some knowledge of algebra, and that's why we're looking at it today. So to begin with, let's talk about probably the most basic thing in statistics, and that is the collection of data. So in order to perform statistics, we need data. And in this case, let's make up some data. So let's pretend that you are selling some candy bars as a fundraiser for your church. All right. And let's say we start recording the number of candy bars that you sell every single day. So you go out on the first day and you sell 2 candy bars. All right. You didn't do so great, but you sold 2. And then on the second day, you sold 4. And on the third day, you sold 8. The fourth day, 1. And then the fifth day, 10. All right. So we have 5 days here, 5 data points, we're going to call them. All right. And we would like to know, based upon the information that we have here, what is the most likely number of candy bars that you're probably going to sell on day 6. So over here, day 6, we don't know how many you've sold because we haven't reached day 6 yet, but we're trying to predict how many we think you might sell on day 6 based on the data that we've already collected. All right? So to begin with our discussion here, let's get a little bit of terminology out of the way. I've already probably thrown a couple of things at you that you don't know what it means per se. One of them might be data point. So what is a data point? All right. Well, a data point is one of the measurements or one of the facts or one of the descriptions that we have taken from a particular event. All right, so the event here is you selling candy bars. Each day we're recording a number. That number is the data point. All right. Now, all of the data points together, we often place them in a set of braces like this, and we call this a data set. So you have a data set, which contains a bunch of data points. So as we go through this lesson, you're going to hear me mention a lot. I'm going to be saying data points a lot and data sets a lot. So it's helpful to know what those are as we go through. All right. Very straightforward, though. Okay. Now, our goal again is to find this kind of the most logical or reasonable estimate for the number of candy bars that you're going to sell tomorrow. And in order to do that, we have to really accept one particular principle of statistics. Okay. And that is essentially that when we have a data set such as this, the numbers in the data set are kind of starting to focus in on a particular number. All right. We're going to call this a central tendency. Okay. So when we talk about statistics and data sets, we are assuming that a central tendency exists in the data. which essentially means that if you were, instead of going out 5 days, if we were to record you going out maybe 100 days or maybe 1,000 days, at some point we would start to recognize that there seems to be a number of candy bars that you regularly sell every single day. And you deviate a little bit from that regular amount, but there's kind of a central number that is kind of you might call it the average, but it's kind of the number that you would expect to sell every single day. And the data kind of backs that out if you were to, extend the data over, let's say, 1,000 days. All right. That's what we mean when we talk about the central tendency. It's the tendency for data to group around a central point. And really, one of the most sought after things in statistics is that central point. That's really a lot of the work that we're going to be doing is going to be to try to find that central point given the data that we have. All right. So to do that, we have 4 tools in statistics, and we have others too, but we have 4 that we're going to be talking about today that help us try to get to that central number. And those 4 tools are the range, the mode, the median, and the mean. All right? So that's what we're going to be talking about today. All right, so just to make it kind of interesting, before we continue on, let's give ourselves another set. So we have your set here. Well, let's say that there is another churchgoer who also is trying to sell candy bars, and let's give him a set as well for the same 5 days. So let's say his numbers are 2 on the first day, 3 on the second day, and 6 and 3 and 6 and so forth. So those are the numbers of candy bars that he sold in the same 5 days. And what we'll do is we'll use our tools here of range, mode, median, and mean to kind of analyze the data on these two. And again, we'll try to give a good estimate on what we think each of you will sell on that 6th day based on the knowledge of how you did on the first 5 days. All right, so let's begin, and let's start by talking about the range. All right, what is the range? And I'm going to pull up the definition, right here. And there we go. So write this in your algebra notebook so that you can memorize it for later. But I've given you 2 things. I've given you the definition and then also the formula that we use to get it. All right. So the definition of the range is very simple. The range is the spread of the data in a set. It's how spread out things are. Do we start, really small and get really big? Are we kind of all in kind of the same area? What is the spread of the data? And to determine that, the formula is simply to subtract the smallest number in the set from the largest. Okay? Now, some sets are not ordered. So this one we have kind of sets, obviously, that are all over the place. We have our data points that are all over the place. We have some larger, some smaller. So the first thing to usually do with your set is to organize your set. And we'll do that right now. To do that, we just rewrite it from the smallest number to the biggest number, the largest number. So all I'm doing is just rewriting the same numbers in order from smallest to largest. That'll make finding several of these other items here much easier. All right, so maybe we'll even just erase our original set here so we don't get confused. This is now our set arranged from smallest to largest. And we'll do the same thing with our friend down here. So he's going to be a 2, 3, but then also a second 3 and a 6 and then a second 6. That'll be his ordered data set. All right, so we've done that. Now we can find the range here. It'll be a little bit easier. The range is simply to take the largest number and subtract from it the smallest number. So the largest number here is a 10, and the smallest number is a 1. So if we subtract those, we end up with 9. So the range is 9. That's all there is to it. The data is spread out over 9 positions, 9 units, you might say. All right. This one down here, we have a 2 as the smallest number. A 6 is the largest number, so we subtract the smaller from the larger, and we get 4. So the range is 4. All right. Very easy. Now let's plot those just to kind of indicate what this range is showing. So let's start with your data, and we'll plug it into the number line here and just try to draw a picture of the range. Okay, so the range here, we have data at 1. Well, data at 1 would be right here. That's where 1 lives. Then we have a data point at 2. 2 lives here. And then we have 4. 4 lives here. And then we have an 8. And we have a 10. Okay, so that's kind of the spread of the data. And if we look at that, we can see that the data is actually spread out over this entire number line that I have drawn here. So if we were to kind of encapsulate all that, we could say that the data starts over here and it kind of goes all the way over to here. That's kind of the spread of the data points. Okay, now let's look at our friend here and see what he has. So for him, he's got a range of 4. The numbers are located at 2, so right on top of this 2. Then we have a 3. 3 is his home is here. Another 3 right on top of it, and then a 6 and another 6 on top of that over here. So his range kind of starts from the 2 and it goes to the 6. So you can see that your range is quite a bit more spread out than his range. All right? And we actually kind of want smaller ranges. Smaller ranges are better. So in this case, for you,
so let's say
we might say, well, what's
churchgoer here
the likely
is
number for our
2
6th
candy
day?
bars on the first
Well,
day.
it could
the
really
third,
be
second
anything
day
within
he
this
sells 3,
range
6,
is
and then
probably
3,
the
and
most
then 6
likely
on the days
area
following.
for the new
so
number
he also
to
has
fall.
a list
And
of,
it could be
of,
a
5
1,
days
it could be a 2,
in
3,
which we
4, it could
recorded
be anything
how
up to
many
a 10.
candy
It could
bars
be a
he
1,
sold.
anywhere
now,
up to a 10.
Let's kind of do some work
right?
on these
so we have
2 sets,
really
and
9
then kind of
different
compare them
possibilities
and see how they shake out
for this,
All right?
this
So
unknown
let's begin
number
by
here. And
talking
all of those
about
would
the
fall
range.
within the range of
That's
this data.
our first
All right?
tool
So down
that we
here,
can
though,
use to
for
find
our
this
friend down here,
central
his
number
range
here
is quite a bit
based
smaller.
on what we have.
So his possibilities for
to determine the range,
his
it's pretty
number of candy bars
straightforward.
sold tomorrow
The range
is going to
and
range
actually, you know
somewhere
what?
between
Let me
2.
grab
It could be a 2,
you
could be a 3, could be a 4, could be a 5, could be a 6.
Let
so
me
we have
grab
5
you
numbers
a
here
definition
that are
for the
likely
range
choices
so that you can write this
for this
in
unknown day.
your
So you can see that the
your
range
notebook.
does actually help us
And
try
let's
to
see, we should
locate
put
that
this-
central
let's put it
number
right
within
over here.
this particular test.
All right.
All right.
So the range
and
is
in
the
this case,
spread
the
of
range
the
is
data
kind of
in a set.
reduced this next
Okay?
number down
So
to a
it's how
possible 9
far
different
apart
numbers.
the data is. How
And for
spread
this,
out
this
the
other
data
guy down
is,
here, it's
over
kind
the
of
data
reduced
field.
it down to
All right?
about
So
5
the
different
formula
numbers.
to find
So
the
the range is more
pretty
helpful
straightforward.
in the second
We're just
scenario
simply
than
taking
in the first
smallest
scenario.
number
All right.
in the
So that's
set,
what range is.
and we're
again,
subtracting it from
very easy to
the largest
compute.
number.
It's just
So
taking the larger number.
we
and
have 2 as
subtracting
our
it from- or
smallest,
subtracting the smaller number
I'm
from
sorry.
it.
Oh, man.
All right. Well, let's move on.
That's-
Let's talk about median now. So the median, I have the definition right here. The median is the center point when the data is ordered from smallest to largest. So to the left here, I've taken the same data sets and I've kept them organized from smallest to largest. That's usually going to be the first step you're going to have to do. And then our next project is to find the median. Very simple. The median is literally the center data point. So if we look at this set, we have 5 data points. The median is the center data point. It's going to be that 4 right there because it's
All
right
right, so
in the middle.
just to
You've got
make
2
it
to the
kind of
right, 2 to the
interesting.
left. So the median is the 4. Very easy. All right. For our friend down here, his median is also going to be right in the middle. So his median is a 3. Okay. So one note here is that the median in both of these cases was very easy because we had an odd number of data points. We had 5 data points, which is odd. And when we have an odd number, there's always going to be a number that's directly in the middle. All right. But what happens if we don't have an odd number? What if we were only measuring 4 days? So let's say, the 4 days were 1, 2, 4, and 8. And I said, well, what's the median for these 4 days? Well, here would be at a little bit of a pickle, wouldn't we? Because looking at the data set, we would say, well, where's the middle? The middle's like right here, right? And there isn't any number right there. If you select the 4, that's not the middle number. We have 2 on the left and 1 on the right. If I select the 2, I have the same problem, only in reverse. I have 2 numbers on the right and 1 number on the left. So there isn't any number that's directly in the middle. So we have a problem. And that's where this third step comes into play up here. So if we need to, if the number of data points is even, the solution around that is to select both middle data points, the 2 and the 4. And what we'll do is we'll add those together, and then we'll divide it by 2. Essentially, we're taking the average of these two middle numbers. All right? So 2 plus 6 is 8, and then 8 divided by 2 is going to be 4. So the median here is still a 4, which is interesting. All right? Oh my goodness. Let me back that up. 2 plus 6. Where am I coming up with that? It's 2 plus 4. I'm adding in my head. 2 plus 4 divided by 2, which is going to be 3. There we go. So the median would be a 3 in this case. All right? Even though there isn't a 3 in the data set, the 3 would still be considered the median. Okay? So that's how you would do it if it's an even number of data points. This is how you do it if there is an odd number of data points. So based on the median, let's just really quickly compare these. So the number of candy bars that you sold, the median would tell us that the most likely amount is going to be 4 for you. And then for your fellow churchgoer, his amount is 3. So if you base things off the median, hey, you're doing better. You sold 4. He should sell 3. Okay? Excellent. So the median's best guess for that central number is the 4 for you and 3 for the other guy. All right? Excellent. Let's move on to mode. Now, mode is an interesting one. Mode is very simple. All you're doing is counting up the number of occurrences of each data point and picking the one that occurs the most often. All right? So the definition is the data point that occurs the most often within a data set. The formula is find the data point in the set that occurs the most often. It's as easy as that, right? So if I look at the data set and I look at all my points, I'm trying to find the one that occurs most frequently. And in this case, they all occur the same number of times. They all only occur once, right? So when everything occurs only once, we would say that there is no mode. There is no mode if everything only occurs once. If I have a data set like this, where maybe it's 1, 2, 2, 2, 3, 6, and let's make it interesting. We'll just put another 3 in here. And I'm trying to find the mode. I would look at all the data points and say, well, I've got 1, 2, 3 2s. I've got 2 3s, 1 6, and 1 1. So the one that occurs the most often is the 2. So the mode for this one is a 2. Okay? And for our friend down here, this is also interesting. This is another scenario that might happen. We look at the mode and we go, wait a minute, we have a tie. We have 2 3s, but we also have 2 6s. So we have 2 numbers that occur more than once, the same number of times. All right? And if that's the case, our mode is going to be 3 and 6. We just give ourselves 2 modes. The mode is 3 and 6. We actually have a name for this. This is called a bimodal set. Okay? A bimodal set. All right? So that's how that the mode actually works. And again, it's just guessing that sixth day, the day that we're focusing on, it's probably likely to occur, the amount is probably going to be the amount that we see the most often. That's what the mode is based on. Here, that doesn't help us at all. Here, we could say, well, he did get 6 twice, and he did get 3 twice, so it's probably a good chance he's going to get a 3 or a 6 for that next day. Okay? So that's how the mode works. All right, let's move on to the next one. The mean. The mean is pretty straightforward, but it's probably the most complicated of the 4 things here. The mean is just the average. So you've probably worked with averages many times in the past. I'm hoping that you have. But mean and average, they're the same thing. Okay? You can really almost use those two words interchangeably. So when they say mean, you should just automatically think average. All right? And if you remember how to find the average, it's not very complicated. The first step is to add the points together, and then you divide the sum by the number of the data points in the set. All right? So if that's the formula, we have our data set here. Let's find the average. So we would add up all the data points, and we would divide it by the number of data points, and there are 5 of them. So we can now work this out. 1 and 2 is 3, 7, 15, 25, divided by 5, which is going to give us a 5. So the 5 is the average. All right? And for our friend down here, his average is going to be the 2 plus the 3 plus the 3 plus the 6 plus the 6, all over, again, 5, because we have 5 data points. And so we end up with 6, 8, and 12 is 20 over 5, which is going to give us an average of 4. All right, so based on the average would tell us that tomorrow you're most likely to sell 5 candy bars. And our friend down here, he's most likely to sell 4 candy bars. All right, so again, based on that, it looks like you're doing a little bit better. Okay, very good. So that is another way to try to find that central number for a data set. Excellent. Let's try a couple examples here and try to just bring home some of these concepts and see how well you do. So we have a problem here. The weights of pillows are measured. The weights were found to be 3, 2, 4, 1, and 2 pounds respectively. What is the range, mode, median, and mean of the pillows? So we're just trying to find, trying to use everything that we've learned to find that kind of that central number. Okay, so let's talk about the range first. And before we even do that, let's take our data points here and let's order them. So they're kind of all over the place right now. Let's write them from smallest to largest. So we have a 1, we have a 2, and I'll cross them out as we go here so we don't miss any. So we have a 1, we have a 2, and then we have a second 2, and then we have a 3, and then finally we have a 4. So that's our data set. How would we find the range? Well, do you remember the formula? What do we do to find the range? Hopefully you remember. The range is simply taking the largest number and subtracting from it the smallest number. We're just trying to find the spread of this data set. So it's going to be the 4 minus the 1, which is 3. So the range is a 3. Let's try the mode. So the mode in this case is, again, we're trying to find the number that occurs the most often. And in this case, it's a 2, right? Because a 2 occurs twice and everything else only occurs once. So the mode is going to be a 2. Then let's try the median. The median, if you recall, well, actually I should maybe give you a second to think about it. What is the median? Do you remember? Well, the median was the middle number, right? Literally the middle number in the set. And that's going to be the 2 because we have an odd number of data points here. So there is a middle number, and that is a 2. Whoops. And then we have the mean. So let's look for the mean. And remember, the mean just means average. Same thing. So to find the average, we add up all of our data points, and we divide it by the number of data points we have, which is 5. And what do we get? We get 5, 8, I think that was 9. No, what am I doing? That's not 9. 7, 9, 11, 12. 12 over 5. which is going to give us what if we kind of bring this down into a mixed number. It's going to be 2 and 2/5, right? So there we go. So again, these are kind of all of the tools that we might use to try to find that central number. And really it depends upon the situation. Sometimes one of these tools will work better than another tool, but you'll often find that they're fairly close to each other. And later on, when you get into statistics, you'll look at more of the subtleties on how to know which one of these tools to use based on the data set that you have. But for right now, you can see that they are fairly all close to each other. The range is 3, which means it's spread out over 3 units, which is a good thing. And I should probably say that the range is the one that doesn't really give us a guess, an estimate at that central number. The range is just there to kind of show us how spread out this data set is. All right. So the smaller the range, the more accurate these numbers will be in determining that central number. If we have a really big range, there's a good chance that the mode, median, and mean may not actually reflect the true value for that central number. Okay, so the range is probably the one that's a little bit different compared to the rest. It's measuring something that's a little bit different. It's not really looking for that central number. It's trying to determine how accurate these other ones will be in finding that central number. Okay, so the range is a 3, somewhat spread out. The mode is a 2. The median totally agrees and says it's also a 2. And the mean says, well, I think it's more of a 2 and 2/5. Okay, so they're all pretty close to each other. So if we were to go and get another pillow of the same brand and measure it or weigh it, we could expect that it's going to be fairly close to 2 pounds. All right, based on what we've seen. Excellent. Now let's go on to the next problem here and see what this one says. So Bill and Joe went fishing. Bill caught 3 fish that were 10, 12, and 17 inches long. Joe also caught 3 fish. They were 4, 5, and 27 inches long. What was the range, mode, median, and mean of the fish caught for each fisherman? So here it's kind of 2 problems in one. They're comparing 2 different fishermen, and they want us to find the range, mode, median, and mean for both of them. So let's go ahead and start doing that. So we'll start with Bill. So let's take a look at Bill's numbers here, and we'll order them. So his catch was 10, 12, and 17. So his data set is 10, 12, and 17. Okay. And if we wanted to find the mode for Bill, well, actually, we'll start with the range, I guess. We'll keep it consistent here. Let's start with the range. The range would be what? Think about it for a second. 17 minus 10, the largest number minus the smallest number. So the range is going to be a 7. All right. And then let's talk about the mode. Well, in this case, is there a mode? No, there's not, because nothing repeats itself. So no mode. Okay, that's one example of when mode is not the best tool to use. All right, because there isn't one. All right, let's look at median. So if we look at the median, it's the middle number. That would be the 12. So we have a 12. And then let's look at the mean, the average. So we have 10 plus 12 plus 17, all over 3, right? Because we have 3 numbers, so it's over 3. So 10 plus 12 is 22. 22 and 17 is 39. So we have a 39 over a 3, which is going to be a 13. All right, so his range is a 7. Median is 12. So, we might expect him to be pretty consistent in catching 12-pound fish or 12-inch fish. And then the mean, well, 13. 13 inches is his mean. The median and the mean, they're fairly close to each other. They pretty much agree. All right, now let's look at Joe. So Joe, his data set says that he caught 4, 5-inch, and 27 inches. Okay, so let's talk about his range. And his range would be 27 minus 4, right? 27, the largest number, minus the smallest number. So his range is 23. And then if we talk about his mode, what would his mode be? Can you tell me? It would be no mode. Because again, nothing repeats itself. All right. How about the median? Try to figure out the median here. See if you can do it. Whoops, median. Pretty simple. It's the middle number, right? So the median is the 5. And then let's find the mean. And once again, why don't you try to do it first? So to find the mean, we're going to take the average. So we're going to take 4 plus 5 plus 27, and we're dividing that by the 3, right? There's 3 data points. So 9 and 27 is 36 over 3, which is a 12. All right, so there we go. We've given them everything they've wanted to know, but let's just take a minute and compare these two. So if we look at Bill's range, it's 7, which isn't too large of a number. If we look at Joe's range, it's huge. It's a 23. So that would mean that Joe's data is probably not the greatest data to indicate what he normally would catch. It seems like it's really spread out right now. And the reason for that, if you look at his data, is because he caught 2 very small fish and then 1 really big fish. It was the biggest fish of the day for both of them. All right. So he was very inconsistent, kind of extreme, extremely small or extremely big. And because of that, he has a very large range. So if we're looking at these 2 sets, we might say that because of the range, this median and this mode are probably going to be a little more accurate in describing Bill's performance than this median and this mean would describe Joe's, just because his range is so big. All right. So based upon that, though, let's keep going. So we have here the median. So Bill's median is 12 and Joe's median is only 5. All right. So it's quite a bit smaller. So that tells you that, its guess at that middle number is a 5. That central number is a 5. He's consistently going to catch at least 5-inch fish. That would be what we would assume based on this median. Over here, the mean, if we look at that, the mean is 13 and the mean over here is 12. So what's interesting here is that for Bill, this 12 and 13 are pretty close to each other. They tend to agree. And the range is pretty small. So we have some pretty good data here showing that Bill probably on average catches somewhere around 12 to 13-inch fish pretty consistently. All right. Over here, Joe, we look at his median, which is a 5, and we look at his mean, which is a 12. They're really not that close to each other. So that would indicate that there's some pretty bad data for Joe. It's just not great numbers. And the reason is, again, because he just wasn't consistent. He caught one that's just way out there. He probably doesn't catch one that big all the time. And that's why his numbers are a little bit skewed. All right. So that kind of gives you an overview on how you can use these 4 tools to judge what might be the central number that the data points are kind of starting to focus in on. All right. Excellent. All right. Let's try one more here just to make things kind of interesting. Let's talk about some golf. Now, I'm not much of a golfer, but hey, let's talk about it here. Let's pretend that you're out on the golf course and you're trying out 2 clubs. Let's say you're trying a driver club and you're trying an iron. Okay? And let's say the driver club, well, actually for both of them, we're aiming for the flag, the hole that's 150 yards away. All right? And you try your driver, and let's say you try 3 shots for each club. So with the driver, you fire away on your first shot, and the driver is, that's going to hit the ball pretty far. So let's say the driver, you really overshoot, and you go all the way over to 300 yards. All right? So you land at, 300 yards, quite far off the mark. And then you fire a second shot. Maybe this one doesn't go quite as far. Maybe it goes to a 225. Okay? And then finally you fire a third shot and you kind of do a worm burner along the ground, and it kind of ends over to, maybe around, we'll call this 125. All right? So that's kind of our 3 shots there for the driver. Now let's say you then pull out your iron and you fire away with your iron And your iron, the first shot, whoops, let's get a different color here. The iron's first shot, let's say it goes over to the, oh, I don't know, somewhere in here. We'll call it the 175 mark right here. All right. And then maybe you fire another shot. This one maybe falls short. Maybe this one's right around the 125. And then you fire a third shot, and this one, maybe this one falls around 160, something like that. Okay? And so now, looking at these two, right away, you're going to be able to see that, gosh, the iron was a much wiser choice if you're trying to get to a hole that's 150 yards away. But let's see if the math backs that up as well. All right, so let's do the same thing we did with the previous problems and try to find, where we might expect that fourth shot to probably go if we were to fire a fourth shot with each of these clubs. All right, so let's look at the data set for the first trial here. And that data set shows that we had a 300, well, we'll write them from smallest to largest. We had a 125-yard shot, we had a 225-yard shot, and we had a 300-yard shot. Okay, so let's find the range on that. And so the range, how do we do it? Largest number minus the smallest number, right? So 300 minus 125 is what? 175. So the range is 175. Then let's talk about the mode. Well, neither one of these are going to have a mode, so we won't worry about it. Let's go right on to the median. The median is the middle number. The median's 225. And then what's the mean? The mean, we'd have to add them up. So we have a 300, we have a 225, and we have a 125. And if we add those up, we end up with 650. So it's going to be 650 divided by, how many shots did we take? 3. So 650 divided by 3 is going to be what? 2, 1 with the remainder of 20, 8, remainder of 2, 218 and 2/3, I believe, yards. Okay, so that's our data for this. Let's move on and look at the data for the irons. So the irons, we have a data set that is ranging from 125 to 160 and to 175. There we go. There's our data set. What's the range on that data set? Well, what's 175 minus 125? It's just a 50, right? And then what do we have for our median? Our median's the middle number. It's 160. And then what do we have for our mean? And the mean, we're going to have to add these up again. So we'll add 175, 160, 125, which is 3, 14, 16, 460 divided by, don't forget the divided by part, we need 3 shots. Divide that by 3. So we end up with, let's see here, 116 would be 5, 1, 3, 153 1/3, I believe. All right. So based on the math behind all of this, what does it tell us? Well, look at the range. The range on our iron is fairly large. It's 175 yards. So that would indicate that, if we're aiming for something that is, maybe at the 125-yard mark, the lowest place in our range here or in a data set, if we're aiming for a 125-yard hole, we could be as much as 175 yards off of our mark. So never use a driver, I guess, for a 125-yard hole, because then you could be 175 yards off, okay? If you, of course, were to swing at the same speed and everything else. Of course, we're oversimplifying this a little bit, but just for this example, it's pretty clear, though, that it would be 75 possible yards off of our mark, which is pretty far. Now, if we look at the iron, we have a range of 50, which is a lot tighter. That means our shots were a lot closer together, right? And if they're closer together, that's a good thing, because then we won't be as far off, right? If the target we're aiming for is within the range, of the shot, we could be at most 50 yards off, and that's it. So that's not so bad. All right. If we look at the medians, the median says that, the fourth shot, or I should say maybe over time, the most often that we'll see the ball land is somewhere around 225 yards. Well, that's way over 150. So that's not a very good number for us if we're looking for 150. If we're aiming for a flag that's sitting at 225 yards, that's great. Then the driver looks like it'd be the one to go with, right? But not for 150. Now, if we use the iron says the median is around 160. So that's not bad, actually. That's pretty darn close to the 150. All right. And then the mean. So the mean says it's 218 for the driver. So that still puts us pretty far away. If 218 is indeed kind of that most common central number, it's still pretty far away from the 150. Now the mean over here says it's 153 and a third. So that's really close. We're like on the green with that. So definitely it seems to be that the iron would be the better choice if the hole is 150 yards away. Okay? So again, hopefully you can see how using these tools really do help us solve real-life problems. Okay? Excellent. Moving on, there are just two things that I want to go over now real quickly before the end of the class, and it has to do with two kinds of problems that you're going to be seeing in your assignment book. So let's start with the first one. This one's pretty straightforward. Well, actually, they're both pretty similar, actually. But let's try it. So Sam will have to take 4 tests over the course of one school term. If he has already taken 3 and scored a 79, 95, 92 respectively, what does he need to score on the last test in order to obtain a 90 average? So he's trying to get a B on his report card. And he hasn't taken that 4th test yet. And he knows that these are his first 3 scores. And so he's trying to ask himself, well, how well do I have to do on my last test in order to get a B still for my average? Okay. So how would we do this? Well, the key to recognize here is that we're talking about average. And you might say the mean. Okay. So if we're talking about average, we have a formula for the average. What's the formula? What is the formula for the average? And I'll just put it here. The average is equal to the sum of the data, right? The sum of all the data divided by the number of data. Whoops. The number of data. That's the formula to find the average. So what's going to happen here? Well, the teacher's going to take the 4 grades once he's taken the 4th one and take the average of them. So we know that the teacher's going to take 79 and add to that 95 and add to that 92. But then he's also going to add to it the 4th test. We don't know what that 4th test is. So we'll just put in an X to represent that 4th test. We don't know what it is yet, but it's got to be there in order for him to compute the final average for the class. So he's going to take those 4 numbers, add them up, and then he'll divide it by the number of tests, which in this case there are 4 tests, right? So that is how he is going to find the average right there. That's the formula for it. Now, what Sam wants to know is how well does he have to do on this X test here to get this average to equal 90% or 90 points? Okay, that's what he's looking for. He wants the whole average to end up being 90, and he wants to know what this X is going to have to be in order for that to happen. So once we have it this far, we should be able to see that this is just an equation. It's an equation with one unknown, and we can solve that. So let's begin by just simplifying maybe. We can add some things in this numerator. Let's do that over here to the side. So we have a 79 plus a 95 plus a 92. We can add those up, which is what, 266, if I did that right. So we have 266 plus x, over 4 equals 90. So now we can solve for x. So we need to get rid of this 4, and it's being divided by 4. So we'll multiply both sides of our equation by 4. The 4's cross out. We end up with 266 plus x equals 90 times 4. Well, that's going to be 360. Now we can subtract the 266 from both sides. These will eliminate, and I'll just kind of continue the problem over here where I have a little bit of room. X is going to equal 360 minus 266 is what? Is 4 is 94. So X has to equal 94. That is the grade that he needs to get on that fourth test in order for his average to be 90. All right? So that's the beautiful thing about average. If we don't know one of the data points, but we do know what we want the average to be, we can figure out that unknown. All right? Very good. So this next one, I want you to try it on your own first, and then we'll do it together. But it's the same concept. We're just replacing the word average with mean. So the mean of 5 numbers is 12. 4 of the numbers are 8, 6, 4, and 15. What is the 5th number? Why don't you pause the video and try this one on your own? All right, so let's do this one together. What do we have? The mean. So the mean is the average. And we want that mean, that average, to equal 12. Okay? How do we find the average? Well, it's going to be a division problem. It's the sum of all the data. What is all the data? It's an 8 plus a 6 plus a 4 plus a 15. Don't forget, though, we have a 5th number in here that we do not know what it is, right? So don't forget that x. All of that has to be divided by the number of data points that we have, and we have 5 of them, so it has to be divided by 5. That is our equation. Now we can solve. So we can start by maybe simplifying the numerator. 8 plus 6 is 14, plus 4 is 18, plus 15 is 33. So we have a 33 plus x over 5 equals 12. Now we can multiply both sides by 5 to get 33 plus x equals 60. Then we can subtract 33 from both sides. And that's going to give us x is equal to 27, right? So that is the mysterious 5th number. All right, that's the 5th number in the set, since we know that the average has to be 12. Okay? Excellent. So hopefully that all makes sense to you, Luke. If you haven't done it already, make sure that you go back in this lesson and write down in your notebook all of the formulas and definitions for the 4 tools of statistics that we learned about today, and start studying those for homework so that you have them clear in your mind, because we will be doing problems on this periodically in the future. All right, well, we will stop there for today. Good luck with the problems, and I will see you tomorrow.